Students, next topic is 4.9 transmission of pressure in liquids or law of transmission of pressure in liquid. Also it is called the Pascal's law because Pascal stated this law. Principle of transmission of fluid pressure. This is another name. Pascal's law or principle of transmission of fluid pressure. What is the statement of this law? Whenever any pressure is applied to any part of the boundary of confined liquid. See, important thing is liquid is confined, means liquid cannot leak. Confined liquid, then pressure is transmitted equally, means pressure will travel equally in all direction, transmitted equally in all direction, irrespective of area. Means pressure will not depend on the area. If area is more or less, okay, it doesn't matter. Pressure will be equally acting on that area. Same pressure is acting everywhere, means whether the area is less or more, it doesn't affect it, irrespective of area on which it acts, and always act at right angle. And in which direction the pressure is acting? At which angle pressure is acting? At right angle, 90-degree angle it is acting. So this is law of transmission of fluid pressure. Now understand it clearly. Suppose this is a vessel, special kind of vessel. Here pistons are there, right? And suppose P and inside liquid is there. It is confined, liquid cannot leak. If P pressure is acting here, then same pressure will be acting here outward, here also it will be acting, here also it will be acting, at 90-degree it will be acting. If here 10 Pascal pressure is acting, then same pressure will be acting here 10 Pascal, here also 10 Pascal, here also 10 Pascal. Means liquid is confined, one thing. Secondly, pressure is transmitted equally, same pressure is acting on these points, and pressure act in all direction. Not equally, in all direction, right side, left side, downward. So pressure acts in all direction also. And at what angle pressure is acting? At a right angle, at 90-degree angle it is acting on these pistons. If pressure acting on the piston is at 90-degree, it is acting at 90-degree every other place also, right? 90-degree only. And next point is irrespective of area. To understand this, I have made one more diagram. This is similar, almost similar diagram. Suppose here pressure acting is 10 Pascal. 10 Pascal pressure is acting on this piston. 4 pistons are there. 1, 2, 3, 4. Then what will be the pressure acting on this smaller piston which have half the area? This have area A, this have half area A by 2. What pressure will be acting here? 10 Pascal. What pressure will be acting on the other piston, top piston, which have double area 2A? 10 Pascal. What pressure will be acting here, which have same area? 10 Pascal. So means pressure acting on these pistons which have different areas. Area is different, but still pressure is same. Acting equally in all, irrespective of area. Means area may be different, but pressure is not different. Pressure is same everywhere. Clear? This is one thing. Now how we use it? How we use this thing? See, suppose here this pressure is 10 Pascal. What is the, we know pressure is equal to force by area. From here calculate force. Force is equal to pressure into area. What is pressure? 10 Pascal. What is area? Small a. So what is the force acting at this piston? 10A. 10A unit force is acting. Now what is the force acting on this small piston? We know force is equal to pressure into area. What is the pressure? 10 Pascal, because same pressure is acting here. What is the area? Half A by 2. So simplify. What is the force acting here? 5A. Pressure acting same, but force acting depend on area on which pressure is acting. If the area of the piston is reduced, with that force acting on that is also reduced. Now come to this one. We know force is equal to P into A. What is P? 10 Pascal. What is A? 2A. So what is the force acting on it? Double. 20A. 10A. Here it will be 20A force. Because area is large. Therefore force acting is also large. And come to this side. Force is equal to P into A. P is 10 Pascal. A is A only because same area. So what is the force acting here? 10A equal. Do you understand? So if you want that more force is acting, then what do you have to do? You have to increase the surface area of that surface on which force is acting. If you increase the surface area, with that force also will increase, although pressure will be same everywhere. Pressure is equally transmitted, but force acting is not equal. Force acting depends on area. If area is different, that force acting also will be different. If area is large, force acting also will be large. If area is less, force acting also will be less. Next topic is hydraulic press. First of all, we'll discuss principle. Principle of hydraulic press is based on Pascal's law. If somebody is asking, name the principle of hydraulic press, your answer is Pascal's law. If somebody is asking, state the principle of hydraulic press. State means you have to give the name of the principle as well as the definition of Pascal's law. Together you have to give, right? Try to understand the difference. Name the principle of hydraulic press. What is the name? Pascal's law, or the principle of transmission of fluid pressure, you can say. But what is, when the question is state the principle, then what is the answer? Along with the name of the principle, you have to give the definition also. State the principle means give definition of the principle, right? And now we will elaborate the principle. We will discuss the principle here. Before we discuss it, try to understand this diagram. See, in this diagram, what is there? One small cylinder is there. We used to call it pump cylinder. What we used to call it? Pump cylinder. In this pump cylinder, there is a piston. Piston means like a syringe. At the back side part, which doctors are moving, it's like this part is there, they are moving forward and downward to just apply the injection. So that part is piston. This is a piston, right? And this piston this cylinder have very small area of cross section, small a is there, small a. And area is given by expression in mathematics by pi r square, where r is radius of this piston, or you can say cylinder, pump cylinder. And this arrangement is connected to the other very larger cylinder. We used to call it press cylinder. And the piston is called press piston. And in technical language, piston is also called plunger. What is it called? Plunger. Press plunger. This is pump plunger, or piston also you can call it. This is larger one, and both are interconnected by this pipe. And the area of this is capital A, larger area, so that is why written with capital A. And formula is pi capital R square, right? And now E is the force acting on this piston. We apply force E on the piston. E is the effort applied, force applied, right? And when we apply force E on the piston, then what is the pressure acting on piston P? What is the pressure acting on piston P? Pressure is equal to what? Force divided by area. What is pressure? Force divided by area. And what is the force? E. E by small a. This is the force acting where? At the piston. Now what is the force acting on the water inside, liquid inside? Inside liquid is there. Whatever liquid, maybe water, maybe some other one. Say water. What is the pressure acting on the liquid inside? Pressure acting on the liquid. is also E over A. Why? Because whatever is pressure acting on the piston, same pressure will be acting on the liquid which is in contact with it. We have already done Pascal's law. Pressure applied on liquid is equally transmitted. Means whatever pressure is acting on piston, same is acting on the liquid. Now beta, this pressure, now next point is pressure acting on piston Q, means second one. But what is the pressure acting on piston Q? You know, according to Pascal's law, pressure acting on P in this pump cylinder is equally transmitted to the other side. Means what is the pressure acting on Q? Same as acting on P. So what is the pressure acting on Q? E over small a. Why? Because Pascal's law is same only. Pascal's law states that pressure is equally transmitted. Right? Now pressure acting on Q is same, E over A. Next we have to calculate thrust or force acting on piston Q. Thrust means force, and force F, you know, P is equal to F by A, and F is equal to what? P into A. P pressure and A area of piston Q. So what is the pressure acting? E over A. What is the area of Q piston? Capital A. So this is the force acting on the piston. Also thrust acting on piston Q in the downward direction is L. Suppose on this piston L load is kept here. L load is kept here. And by applying force on this pump piston, E force, suppose that this piston and this piston both are static, means neither they are going up nor coming down. It means whatever force, upward force is acting on Q, which we have already calculated, Q is equal, the force is equal to E over small a into capital A. This is the thrust acting in the upward direction on piston Q. Okay, acting upward. Same is the downward thrust, that is L. Means L acting downward and force acting upward on piston, thrust acting upward on piston Q is same when there is equilibrium. Equilibrium means this piston is neither going up nor coming down. That is equilibrium. And now if that happens, L is equal to thrust. So L is equal to downward thrust is L, and what is upward thrust? We have already calculated here. Okay, E over A into capital A. So both are equal, right? Now take this E to the other side as denominator, L divided by E, and right side it will be capital A by small a, right? And now this ratio of load to effort, L is load to effort ratio in science, physics, it is called mechanical advantage. So mechanical advantage is equal to what? Capital A by small a. And what is the formula for capital A? Pi capital R square. What is the formula for small a? Pi small r square. Capital R is the radius of larger piston, small r is the radius of smaller piston. Pi cancelled, we have relation capital R square over small r square. Right, so two formulae of mechanical advantage are there. Therefore, one is capital A over small a. What is capital A? Area of larger piston divided by area of smaller piston. And the second one, in terms of radius, square of radius of larger piston, square of radius of smaller piston. So these are formulas of mechanical advantage. But beta, you have to understand what is mechanical advantage. I am going to give you one example. Okay, and then only I will start the next topic. See, if you have to draw a screw into the wood or a screw into the wall or anywhere, can you do it with your hand only? With simple hand, take the screw and push it into the wood, or simply move it like this and it goes inside. It's not possible. Normally it is. For normal human being, it is not possible. Then what we are doing? We are taking screwdriver. What we are taking? Screwdriver. And with the help of screwdriver, we are able to drive the screw into the wood very easily. So what does this machine, screwdriver, do for us? This you have to understand. See, when we are driving screw into the wood, between the screw and the wood, there is friction, and that friction we have to overcome. If we overcome that friction, then the screw will go into the wood, is driven into the wood. But if that friction is not overcome, you cannot drive the screw into the wood. And you know that friction between the screw and the wood is very large. Say, just example, say 2000 Newton force friction is there. And normal human being, we cannot apply 500 Newton force, because this is a limitation of all human beings. We cannot apply infinite amount of force, right? So we apply only less force, only 500 Newton. So now we apply 500 Newton, but the required is 2000 Newton. Do you think the screw can be driven into the wood? No, because required is 2000. We are applying maximum is 500. Do you understand? Then what does the screwdriver do for us? What it does for us? When we use screwdriver, we put screwdriver on the screw, and then we apply force on the screwdriver, and then screwdriver is driven into the wood. Clear? Now what is the purpose or function of that screwdriver? What screwdriver do for us? How much force is required for the screw to be driven into the wood? 2000. How much we apply directly with the hand? 500. Then what happens with the screwdriver? That means when we use screwdriver, force acting on the screw through screwdriver will be 2000 Newton or more. Then only screw is driven into the wood. Clear? So what does the screwdriver is doing for us? What is doing for us? That screwdriver is multiplying our force. That 500 Newton force is multiplied 4 times by screwdriver. 4 times of 500, 2000 Newton. So when that screwdriver multiply, we apply just 500 Newton force on the screwdriver, but the screwdriver multiply our force 4 times to make it 2000. And when 2000 force act on the screw, it is driven into the wood, because that much friction is there between the screw and the wood. You got it? Okay. So what is the function of that screwdriver? It multiply the force which we are applying on it. We apply force on the screwdriver, and screwdriver multiply our force 4 times, okay, or more times, less time, depend on the screwdriver. Different screwdriver have different mechanical advantage. So then it is driven into the wood. So that screwdriver is giving us advantage. What is that advantage? That advantage is in terms of load lifted to effort applied. Load lifted to effort applied. How much load? Load means friction between the screw and the wood, 2000. What is the effort? 500 we apply. So 2000 by 500, what is the answer? 4. So what is that 4? It is the advantage given by the screwdriver to us. Means whatever force you apply on the screwdriver, it will multiply that force 4 times. And then the work, means driving of screw into the wood, is done. Same way, beta, this is also a machine, hydraulic machine, hydraulic press, it's a machine. So machine always give us some kind of advantage. So what is the advantage here? We apply less force here, and the large load will be lifted. Right? Large load will be lifted. So what is mechanical advantage? It's a ratio of load lifted to effort applied. See, I spent a lot of time on this. Try to understand. Listen this video carefully number of times. And all of you, you have to subscribe to this, because how I come to know that you are watching the video or not? I want to know this fact, okay? And subscribe to this and see the video completely, not just once, many times. See, I come to know how much you are watching, how many people are watching my videos from YouTube. Views are there, subscribers are there. And make your subscription public, not private, public only. Then only I will check you who is studying my videos. Clear? Okay. Next, construction of hydraulic press. It consists of pump tube or cylinder of area of cross section small a, that is pi r square, connected to press tube of area of cross section capital A pi r capital R square, such that area A, capital A, means the larger piston, that is press piston, is much more than area of the pump piston. Lower end of the pump tube is connected with a smaller tube, which is further connected with an underground water tank. See, now I explain it. See, look here carefully, then I will read, otherwise it's useless. See, from the main part, first of all, this is called a pump cylinder, smaller one, right? And there is a pump piston, small area of cross section, small a pi r square, it is there, right? And this piston is called either pump plunger or pump piston, we call it, right? And lower end, here you see there is a tube which connect this pump cylinder with the underground water tank. This is underground water tank is there. Okay, underground water tank is there. Do you understand? Okay. Now you see there is another part here, V1, pump foot valve. What is valve, first of all? In Punjabi, you know, when you are going to fill air in the tires of your cycle or scooter or bike, what you are saying? Bal. A bal kharab ho gaya sada. Oh, bal, actually it's not bal, it is valve. Okay, we Punjabis just change the word a lot. That is valve actually. Air valve we call it. Right? So what is the function of that? That allows the air to go into the tube but does not allow it to come out. This is the function of the valve. All valves have this kind of function only. Whether they allow the material to move in one direction but does not allow the reverse backward movement. So this valve also allow the liquid to go up but does not allow that liquid which is there in the pump cylinder to come down. This valve have that function, V1, right? Then this first of all construction only, this is, cylinder is connected with another tube, sidewise tube, and that tube is ultimately connected with larger cylinder, that is called press cylinder. What is it called? Press cylinder. Large cylinder. That cylinder is connected with the press piston or press plunger, capital A, and area of cross section capital A pi capital A R square, you can say. And this piston is in turn connected with a platform, right? And on the top, on the side, you know, walls are there, concrete walls are there. On this concrete wall, one shed is there, concrete shed, that is immovable, cannot move up or down. Right? And here if also you check, there is another valve V2. So what is the function of this? It allows the liquid to enter into this press cylinder but does not allow the water to come out of this cylinder. Does not allow it to come out. Allows to go in but does not allow it to come out. And here there is a release cylinder. This release cylinder we are using only when we have to stop the working. Right, this is general construction of that. And just see that here also two cylinders, here also two cylinders only. So principle is same only. Now in this diagram actually there are two machines. One press, that is hydraulic press, and another one is this handle. You know, nalka, that type of handle is acting here. What is the use of that nalka? Can you lift the water from the top of the water pump simply by using hand and pulling it up? Can you do it? Nobody can do it. When you have to remove that part out of the water pump, a lot of force is required. Some arrangement is kept there, then only it is pulled out. But with the help of that handle of the water pump, you can easily, so small kid also can operate it and take the water out. So that means that is also a machine. Handle of the water pump is a machine. So this kind of machine is applied here, we call it lever. That is also lever. Here we apply force, and this lever, what is the function of screwdriver? Multiply our force. So what is the function of this lever? It also will multiply our force. So we apply less force here, that is multiplied by the lever and act on the piston here. Right, that force acting on the piston divided by area small a, that is pressure acting on the piston. That pressure is given to the liquid inside, and according to the transmission of liquid pressure, that pressure is transmitted to the other side. That pressure is acting on the press piston. And you know, this press piston have larger area, and we know force is equal to pressure into area. Because area is large, so force acting on this press piston will be very large, very large. Sometimes 400, 500 times the force which we applied here, or even more. Clear? So this way, this platform will be lifted up. This is construction, right? Now working, very carefully you understand. In the beginning there is no water here and here, no water is there, nothing, only water is there in the underground water tank. This piston is here at the bottom, and this V1 is closed, valve V1 is closed. By operating this handle, this piston is lifted up. When this piston is lifted up, okay, the air above this piston is just imaginary piston I am making here. This is piston position of the piston. When this piston is lifted up, the air above the piston is swept up. Air is swept out. The piston is moved from here to here. The air above the piston will be taken out. So what is inside? Low pressure area. Low pressure area will be created inside the piston. When pressure here is low, but what is the pressure acting on the underground water tank? Atmospheric pressure. So liquid water will always move from high pressure to low pressure. So water will come up. When the water will come up, it will open the valve V1. The valve V1 will be opened and water goes inside it. Do you understand? This cylinder, pump cylinder will be filled with water. Again I am saying, again try to understand. This, in the beginning, suppose the position of this piston is here. With the help of this lever, the piston goes up and down. Right? So it is here. When this goes up, the air above it is pushed up, swept out. So inside no air, less air means low pressure area. Less air means low pressure area. And here high pressure. So high, liquid always move from high pressure to low pressure. So water moves up. And open the valve V1 and the water is filled in this pump cylinder. Clear? Then we keep on operating this handle. Then this piston moves down. When this piston moves down under the weight of this water in the pump cylinder, under the weight of this water, this valve V1 is closed. V1 allows the liquid to go up, cannot allow it to come down. This is the function of it. Right? So V1 is closed, so water will go to the other side. So when water is pushed up to here, then pressure act on V2 and V2 is opens, valve V2 opens and the liquid enter here. And the pressure is acting on the press piston and it start, in the beginning it is here only. In the beginning the press piston is here. So when liquid enters, this press piston start moving upward. And we keep on operating it. Okay, water from the underground water tank keep on going into the pump cylinder, and from here it goes to the press cylinder side. Right? And therefore this piston is keep on lifting up and up and up and up and up. So keep on applying force here, this piston keep on lifting up. Right? And then on the platform, cotton wheels means cotton, loose cotton is kept there. And with the help of platform, loose cotton also keep on moving up and up and up and up. And because this is concrete shed and this is platform is moving up, so cotton bales are sandwiched and they are pressed tightly and make a very tight pack. And with the help of steel strips, those that pack is put together and then it is transported from one place to another place. In place of cotton bales, there can be jute also. Jute also can be tight packs of jute also are pressed into tight pack. Jute is pressed into tight packs, right? That is also that also can be done. Clear? So this is how the hydraulic press works. And suppose now you are at the end of the works, so you have to stop working. Then what is done? This release valve is opened and water in the press cylinder will come back into the underground water tank and the machine is stopped. Right? Machine is stopped. And now if the difference in area of capital A and small a is very large, suppose, see, I'll show you one example, one numerical. You will understand what is the thing here. See, here you see this one, somewhere, this one you see. Area of cross section of pump plunger very less, 0.02 meter, and press is 8 meter. So 8 divided by 0.0, see 8 divided by 0.02. So if I simplify, you know what is the answer? 400. Mechanical advantage become 400. Means even if I apply 1 kgf force, then how much it becomes? 400 kgf. See, this is this much high mechanical advantage or even higher is possible. Right? A small student can lift very large body with the help of this hydraulic press. So beta, this is what is discussed here, instruction and action. Right? Go through it, read it nicely. If there is problem, you can ask. Now uses of hydraulic press. It is used for compressing straw and cotton bale. Beta, I'll talk in Punjabi, only then you can understand. Chadu hunde ne, chadu tille wale. You know, from Odisha side, these straws are coming from there and they are tightly packed in a very strong packs are there, tightly packed. How we can bring them in a loose form? Simply loose sit the truck च भर जाना ट्रक जल्दी. Okay, तो उन्हें tight करना पैंदा, tight pack बनाने पैंदे. Hydraulic presses are used there, and those tight packs are put and they are coming here through the trucks or railway and whatever. Then here some people they are having factories. They make small chadus, proper and brand name and all, and then they distribute to the shopkeepers and we are getting. So straw, chadu jeda marji type da hove, whatever type it is. So we are getting those things transported from from Odisha or West Bengal or Andhra Pradesh to India, to northern side, through by making tight packs only. First tight packs are made, then only they can be easily transported. How we can transport loose material? It is not possible, right? So, and cotton bales also are transported like this. Punching holes in the metal. Now this is just a modification. See, if in place of this platform, if we have a sharp, in place of this platform, if we, this is a press piston, and in place of platform we make a needle like this, sharp needle. And if you place a metal here and the concrete shed also have a hole inside here, somewhere hole is there. So this sheet will be sandwiched between this sharp needle and the concrete shed, and this will keep on going inside the sheet and make a fine hole in it. So by just modification of this machine, hydraulic machine only, we can change it into punching machine also to make punch in the metal. And it's not easy to punch holes in the metal, but this can be done with this. It is used for extracting oil from the oil seeds. Now see, if say only just a press I am showing. See, if the rigid support is like this, it is like this, very close to the, this is rigid sport. I'm just making a rigid sport. This is a rigid sport, right? And here seeds are kept, and this is piston. It keep on moving up. Then what will happen? These seeds are crushed between the rigid sport and the piston. And when the seeds are crushed, what they will give? Oil. So by just modification, jugaad technology, we can convert the hydraulic press into oil extracting machine also. It is used for giving specific shape. You know that the shape of the roof sheets, GI sheets are there. ठीक है, इदां दियां sheets ਹੁੰਦੀਆਂ ਜਿਹਨਾਂ ਛੱਤ ਬਣਾਉਣ ਲਈ यूज़ ਕਰਦੇ, ਲੋਹੇ ਦੀਆਂ ਹੁੰਦੀਆਂ, GI sheets they are called. And how they are given this specific shape? So if this platform is having this shape, concrete or shed also have this shape. If you place a sheet of iron here, what this iron sheet, which shape this iron sheet will get? It will get this kind of shape only. So specific shape also can be given to iron sheets with the help of hydraulic press. Okay, next it is used for servicing automobiles. See, when a car has to be repaired, then from it, suppose it has to be repaired from the lower part also. Then what to do? One platform is there on which a car is made to stand. This is a car, whatever, like this. This is a car, and car is made to stand on the platform. And by applying the, by operating this one pump piston and that lever, we lift the press piston. In place of cotton wheel, car can be placed there. So car will be lifted up, and when it is lifted up, then the mechanics, they can repair from below it, from lower part, or they can wash it nicely. Right? So in the servicing station, these kind of lifts earlier, these kind of lifts are there. Nowadays automatic lifts are there. Okay, with the changing time, technology also changed. So this is also possible, right? So these are the things we have to do. Next topic is hydraulic brakes. Hydraulic brakes, they are also hydraulic brakes also depend on Pascal's law for transmission of pressure. Now we'll study hydraulic brakes. Hydraulic brakes. Hydraulic brake, they are based on, again, principle of transmission of fluid pressure, that is Pascal's law. Hydraulic brake consists of master cylinder, one part, which is filled with thick oil called brake oil. In the master cylinder is fitted airtight piston. I'll show you in the diagram afterwards, and is connected with the brake pedal through levers. Right? I'll show this part. See, these are brake pedals on which a driver used to put the foot and press it down. Force applied by driver on the brake pedal is multiplied by these levers, and that force act on this piston. This is piston of the master cylinder. This is a master cylinder, and in this master cylinder, brake oil, thick oil, is filled in it. Okay, force acting on the piston divided by area. We know pressure is equal to what? Force divided by area. So pressure is acting on the piston, that pressure is transmitted to the brake oil, and the pressure from the brake oil is transmitted to two wheels. One wheel is this, second wheel is not shown, but the structure of second wheel will be same only, construction will be same. And this fluid, brake oil, is pushed into another cylinder called brake cylinder. Brake cylinder has two pistons on both sides. Right? So pressure applied in the master cylinder is transmitted to brake cylinder. right? Brake cylinder. When pressure is transmitted to brake cylinder, that pressure acts on these pistons outward, and these pistons are pushed outward, and with the piston on both sides are attached brake shoes. Okay, the brake shoes are there, and those brake shoes come in contact with this iron wheel, that is wheel rim. When brake shoes come in contact with the wheel, then there is friction between the wheel rim and the brake shoes, and friction always opposes the motion. Therefore the motion of the wheel is decreases. That means brakes are applied. If brakes are applied with more force, then ultimately vehicle will stop. If with less force, then it will slow down. Right? Now these shoes are in contact with wheels. So when these shoes are in contact with the wheels, then this spring which is attached with the shoes, brake shoes, that is stretched. And stretched spring develop a restoring force in it. Restoring force means this spring, stretched spring, bring these shoes back to normal place when foot is taken off the brake pedal. When foot is taken off the brake pedal, then restoring force developed in the spring, restoring spring, bring these shoes, brake shoes, back to normal place, because spring is stretched when the shoes are moving outward, when brakes are applied. Brakes are applied. Now we have to put off the brakes. Then foot is taken off the brake pedal, and this spring, restoring spring, bring these shoes back to normal place, and the fluid brake oil from the brake cylinder enter master cylinder again. Okay, this is how brakes are applied. Same method is applicable to the second wheel also. Do you understand? So what is important, beta, in this case of hydraulic brake? Diagram is important. What is the principle of this brake? This hydraulic brake, that is important. These two things are important, and of course working also you have to learn. Right?